Hello everyone. In this video tutorial, we will discuss about error detection techniques in computer networks. So let us start the agenda. The contents we are going to discuss are what is error detection, what is an error, and what are its types, and the error detection techniques such as parity check, checksum, and cyclic redundancy check. Now let us start with the definition of error detection. The error detection can be done at the data link layer of OSA reference model. The data link layer is responsible for error detection and error correction techniques. So in the data link layer, it uses an error control techniques to ensure that frames, that is bit streams of data, are transmitted from the source to the destination with a certain extent of accuracy. When the data is transmitted from one device to another device, the system does not guarantee whether the data received by the device is identical to the data transmitted by another device. An error is a situation when the message received at the receiver end is not identical to the message transmitted. Let us see what is an error. When bits are transmitted over the computer network, they are subject to get corrupted due to interference and network problems. The corrupted bits leads to spurious data being received by the destination are called errors. The errors are categorized into three categories. One is single bit error and multiple bit error, and third one is burst error. Single bit error. In the received frame, only one bit of a given data unit is changed from 1 into 0 and 0 into 1 means that kind of error is known as a single bit error. A single bit error does not appear more likely in serial data transmission. These single bit errors mainly occur in parallel data transmission only. And what is a multiple bit error? In the received frame, more than one bits are corrupted, then it is called multiple bit errors. Next one, burst error. In the received frame, more than one consecutive bits are corrupted means then that kind of error is known as a burst error. The duration of noise in burst error is more than the duration of noise in a single bit error. These burst errors are most likely to occur in serial data transmission. The number of affected bits depends on the duration of the noise and the data rate. Let us move on to error detection techniques. Error detection involves checking whether any error has been occurred or not. There are three main techniques in error detection mechanism. They are parity check, checksum, and cyclic redundancy check. Let us come to know what is a parity check. The parity check is done by adding an extra bit to the data to make a number of ones either even in case of even parity or odd in case of odd parity. While creating a frame, the sender counts the number of ones in it and adds the parity bit. The parity check is divided into two categories. One is single parity check and another one is two-dimensional parity check. The single parity check can be divided into two categories. One is even parity and the another one is odd parity. In case of even parity, if a number of ones is even, then the parity bit value is 0. If the number of ones is odd, then the parity bit value is 1. In case of odd parity, if the number of ones is odd, then the parity bit value is 0. If the number of ones is even, then the parity bit value is 1. This kind of parity check is suitable for single bit error detection only. Then, two-dimensional parity check. The performance can be improved by using the two-dimensional parity check because it organizes the data in the form of a table. The parity check bits are computed for each row, which is equivalent to a single parity check. So the parity check will be computed for each row and for each column. So in two-dimensional parity check, a block of bits is divided into rows and the redundant row of bits is added to the whole block. At the receiving end, the parity checks are compared with the parity bits computed from the received data. The two-dimensional parity check have some drawbacks also. If two bits in one data unit are corrupted and two bits exactly in the same position in another data unit are also corrupted, then 2D parity checker will not be able to detect that kind of errors. So this technique can be used to detect the 4-bit errors. So let's come into the checksum. Checksum is another error detection technique based on the concept of redundancy. The checksum is divided into two parts, checksum generator and checksum checker. The checksum generator have been generated at the sending side. The checksum generator subdivides the data into equal segments of n bits each. And all these segments are added together by using the ones complement arithmetic. The sum is complemented and appended to the original data known as checksum field. The extended data is transmitted across the network, and this is an example for example data unit. In this particular data unit, the data is divided into four segments. All the segments are added together. After adding those segments, the sum has been complemented. After complementing the sum, it will be sending with the data. That is, the data along with the checksum value have been transmitted from the sender to the receiver by using the checksum generator. After that, a checksum checker that is verified at the receiving end. The receiver subdivides the incoming data into equal segments of n bits each, and all these segments are added together and then they are generated a sum. That particular sum have been complemented. If the complemented sum is 0, then the data is accepted. Otherwise, that is, the sum is a non-zero value, then in that particular time, the data have been rejected. So this is checksum process. And next we are going to see is cyclic redundancy check. It is also an error detection technique. In the CRC technique, a string of n zeros are appended to the data unit, and this number is less than the number of bits in the predetermined number known as division, which is n plus 1 bits. Secondly, the newly extended data is divided by the divisor using a process known as binary division. The remainder generated from this division is known as a CRC remainder. Thirdly, the CRC reminder at the end of the original data replaces the appended zeros. This newly generated unit is known as the receive. No, it is sent to the receiver. The receiver receives the data followed by the CRC reminder. The receiver will treat this whole unit as a single unit, and it is divided by the same divisor that was used to find the CRC reminder. If the resultant of the division is 0, which means that it has no errors and the data is accepted. If the resultant value of the division is non-zero, which means that the data consists of an error. Therefore, the data have been discarded. So that's all about the error detection techniques. Thank you.